Hi, everyone, and welcome to the Weekly Space Hangout for Friday, March 18th, 2016. I'm Fraser, Cain, publisher of Universe Today. And with me this week, finally, the internets from Spain have stabilized, and we got Dave Dickinson. Hey, David.
Hey there. We're just outside of Seville in our latest Airbnb right now, so it's weird to be doing this at night. It's 8 p.m. here, so.
That's good. You could set a telescope up outside and live stream, and it'd be like the virtual.
we
You can do this.
Combination, exactly.
Yeah. You can do this and then go to dinner.
Oh, exactly.
Right.
Yeah, in Spain, you probably, the Mediterranean dinner's usually, you would be early if you're 10 p.m.
Right.
or so.
Well, you go out for drinks first and then dinner.
And then dinner, yeah.
Exactly.
Yeah,
Dinner's
dinner at
usually
11
mostly
o'clock.
midnight, so.
Yeah. We've got Kimberly Cartier. Hey, Kimberly.
Hey Fraser, hello viewers. Welcome to the Penn State Astronomy Department.
Wow, it's stunning.
It's exciting. It has
it really is. The whiteboard,
and
so much math.
Well, I thought that conference room looked familiar.
Yeah, it's very unique.
Yeah. Can you see So is there some like super famous Penn State astronomer that maybe you can see their whiteboard etchings if you just dig far enough?
Well, if only. If only. I think
what was like some big discovery that was made at Penn State?
Penn State actually has the astronomer who discovered the first pulsar planets.
Right.
Yeah, that's Alex Wolshan. He wasn't at Penn State at the time, but we snagged him.
Oh no. Okay, so that math isn't in there then. All right.
No.
And wasn't the first pulsar planet the first planet? Exoplanet?
Yep.
Depending on how you define planet, yes.
Small
We're going to go with yes.
object orbiting a star.
Well, is a pulsar a star, or is it a stellar remnant, Fraser?
I'm gonna say it's a
still
star,
raging.
but I can see that I'm now arguing way out of my element. So I'll leave that to the astrophysics. All right, and we got Paul Matt Sutter. Hey, Paul.
Oh yeah, me. Hi, everyone.
And you are our special guest as well. Self-invited special guest. One of the I guess one of the benefits of being part of the Weekly Space Hangout is that you get to use this tool to toot your own horn when you need to, and
prepare to be tooted.
All right, but we're also going to talk about this really important thing that Dr. Sutter wants to talk about, but also we're going to talk about the launch of ExoMars. We're going to talk about Comet P252 Linear. Is this the bright comet that the universe owes me? We're going to talk about disappearing quasars and the afterglow fast radio burst. So, all right, Paul, tell us. And have you got any news as well, or have you just got what?
I can do news if you want. If you send me a link, I'll read it while I'm talking. I can do that.
No, we'll let you sort of tell us what's going on. So tell us what project you're working on, an exciting Kickstarter that maybe we should all participate in.
Yeah, this is such an exciting project. I've been working on this for about 10 months. I started last April, May-ish, and as you know, everyone here in this hangout is really passionate about communicating astronomy and communicating science and bringing science to new audiences, and we all share that in common. And I wanted to try something where I brought astronomy to an audience that's typically isn't exposed to astronomy or space or even science topics. And to do that, I partnered with a dance company here in Columbus, a company called Seven Dance Company. And I shared with them some stories, some scenarios, some pictures. And together, we've choreographed a set of dances telling the life stories of the stars. So starting 13 billion years ago in the Dark Ages with the revolution of light, the first stars to come on, telling the stories of two galaxies colliding, which creates a generation of new stars, telling about a companion that becomes a black hole, telling about a supernova that sends one last message that can be seen across the universe, telling all these stories through dance. And we've created a performance out of it that's premiering on April 21st in Columbus. And it's the live production is all set. It's going to be like an hour and a half long thing where it's interleaving these dance episodes and then narration by me where I'm telling the story, and then various episodes will be brought to life through these dance pieces that we've been working on. And then the Kickstarter you mentioned is to create a film of that live performance. So the live performance is a go, and we want to bring out from some film producers and some camera people and some editors to capture that live performance so that we can share it with the world. So it's not just contained in Columbus, Ohio, so that anyone in the world can see it and share it. And then also as a part of that production, we're creating a 360-degree film for virtual reality headsets and for planetariums. So it'll be hopefully distributed to planetariums around the world too.
That's crazy, and it sounds expensive.
It's not the cheapest thing. Our Kickstarter, our goal is $25,000. That pays for the camera crew to come out, rental of camera gear, record, our dress rehearsal the night before, and the live performance, and then editing times, any little special effects we want to add, so that we have a nice, polished, finished project. The leader of the film production side, his name is Kai Stotz, and you might recognize his work because he's like the official documentary filmmaker for the LIGO collaboration. And in the LIGO's big announcement a few weeks ago, they showed videos, they had interviews. That was all his work. And so he makes films based on LIGO and all sorts of other science topics. We're so lucky to snag such a talented guy.
So how much astrophysics did you have to teach the dancers to be able to accurately portray, you know, merging galaxies, active black holes, things like that?
Yeah, so the fun part about this is I wasn't sitting there dictating the movements to the dancers because they wouldn't let me blow them up. You know, they like valued their lives and stuff. Yeah. So, you know, we couldn't go like fully physically accurate, and that wasn't the point anyway. What I did was I would pick a scenario like merging galaxies, and I would sit down, we'd sit in a big circle in their studio with the choreographers, with the dancers, and I would just share the scenario, show them some pictures, show them some movies, and then allow the dancers and choreographers to be inspired by that, to create their own movements, to be able to tell their own story, to find some like emotional human hook into that story. So instead of just trying to represent two galaxies slamming into each other, now we're telling the story of like a tragic love where two lovers are drawn to each other and that they know it will end in disaster, it will end badly, but they can't help themselves. And using that kind of emotional context together with some of the physical hints and scenarios that I gave the dancers, they created like a 5-minute piece from that tells that whole story. And so we would go in stages. We would go back and forth where I'd share something, they'd create a dance, I'd watch it, you know, we'd talk about it, maybe they'd tweak something, maybe they'd add something, and we'd layer it over the course of the past 10 months.
Right. So you're there and like, I'm going to need to see more tidal tails, things like that.
Or I wouldn't boss them around because I don't want to tell choreographers what to do. I'm not an expert dancer. But something that really surprised me that is a happy byproduct of this is I would share with them some pictures and, you know, some descriptions, and I'd just let them go for it. And then naturally, as the dancers and choreographers are figuring out how to move people around, how to express this in movement, they would come up with certain arrangements of dancers or certain patterns that I didn't share with them that are mirroring the physics. So things like tidal tails or the behavior of satellite galaxies when main galaxies merge naturally arose from the dances just because the dancers had to think like, okay, if this happens, you know, what needs to happen to these three dancers over here? What do we do with them? And just the natural way that they would have those dancers behave ended up, you know, mirroring the physics to a surprising degree. It was actually really exciting to see this come about naturally.
We got a question from Nancy Graziano.
Yep.
Have any of the dancers, choreographers developed an interest in astronomy as a result of the project?
They absolutely have. In fact, what this company was really excited about, why they actually answered my email when I sent like a random email, I knew none of these people before, to the artistic director of the studio. At first, she thought I was a crazy person, which I am a crazy person,
Not
but
too wrong.
she's
Okay.
not. Yeah, she's not wrong. But I sent this email. She said, "Well, let's try it out. This seems like a cool idea." What really excited Kasia Kramer, that's her name of the artistic director, and the dancers, is that they've never done dances themed from this before. This is like a whole new, fresh set of stories that they can tell, that they can be inspired from as artists, as dancers, that, like nobody tells these kinds of stories through dance, and they get to be the ones that, explore and mine all this great new territory. And because of it, because they're approaching this topic through dance, they get to learn astronomy. Now, these are people who have been doing dance for years. They've never really been interested in space or astronomy, but because they're approaching this topic from something that they're familiar with, now they're hooked. They actually like ask me more. Like, hey, Paul, could you talk in more detail about this topic? And so that's exactly what we're trying to do with the whole performance, is that you can come on this night, or you see the film, and you see a professional, beautiful dance performance. And if you've never been exposed to astronomy before, but you're a fan of dance, you can go enjoy a dance performance, and then, oh, by the way, you happen to learn a little bit about the way the universe works. And if you're a science geek already, then here's a new way of telling these stories that you're already familiar with.
Right. So you'll be like elbowing your date and saying, no, there, you see there, those are the satellite galaxies getting spun out.
Exactly.
Merging into a giant elliptical galaxy.
Exactly. So we're saying, oh, go ahead, Dave.
Is there any video clips of this online already? Or?
So on the Kickstarter, there's a video that our film producer put together. There's what we have is just kind of behind the scenes shots of the dancers practicing and talking to each other. Also on the Kickstarter page, there's a set of photographs that we've taken where we've kind of lined them up next to each other with a certain scenario, like galaxies merging, and then how the dancers interpret that, or the formation of the first stars and how the dancers have interpreted that.
Very cool.
Awesome. Nancy actually also asks, are you using an original music score, such as the Planets, etc.? So where's the music coming from?
The music is chosen by the choreographers. We have about 4 choreographers doing about there's a total of 9 episodes in the performance, and they chose the music based, again, on the scenario. So they would look at the scenario, look at the description, look at the pictures, talk to me, and just think about how they want the dance to come together, what kind of emotional theme they want, and then they went after certain pieces of music to best convey that and work with the dancing. And it's the same thing. We have one of the best lighting designers in the country working with us. We're lucky to have her, Mary Tarantino. She's been doing sketches of our lighting, and it's the exact same process. I just share what I know and what astronomers and scientists know, and she uses that to inspire her as a designer.
So, and I mean, one of the great things about Kickstarter, right, is in the olden days, right, you had to be nearby, and you had, to be a patron of this kind of thing. Now you can sort of make this worldwide. You can offer outcomes. You can offer various, rewards to the various people who contribute. Mm-hmm. So what kinds of rewards, you mentioned a few earlier on, what are some of the rewards that Kickstarter benefactors can receive?
Yeah, we've got T-shirts with our Song of the Stars logo, which is a very cool logo that is a pair of dancers turned into a constellation. We're going to make program books with stills from the film, with my narration, written by me, so it's telling this story with these beautiful pictures of the dancers on stage, under the right lighting, in their costumes. If you're at higher level, you get to be an associate or even an executive producer on the film. So you get credited as being, the person that really helped pay to make this happen.
Awesome. Now, what about? Now, you said it's going to be played at, in your hometown. Any plans to sort of take it on the road if it's, if successful?
You mean when it's successful?
When
that's the attitude
after
we need.
its inevitable success.
Yes.
Will people be able to get a chance to see it?
We're hoping so. I mean, there's dreams that we have. The first job is get this done because nobody's really taken like a professional dance company of this style where it's this collaboration between artists and scientists. There have been dances themed from science before, but I think this is the first time where we're letting the artists be inspired. We're not trying to dictate their movements. And so we just want to get it done, make it happen, and we will probably do follow-on performances in Columbus, and if we can get enough funding and support, we definitely want to take this on the road.
Yeah, that would be really cool. And I could just imagine at every major discovery, you guys offer up a dance interpretation for the people who maybe find the traditional explanation a little not dancey enough.
Exactly. There's things that dance can communicate that just words or pictures can't. It's a new way of describing the same scenarios, and that will resonate and connect with new kinds of audiences.
Yeah, I just didn't understand when I heard the words, but when I saw the dance, general relativity finally clicked with me.
You get it. You get a little bit of intuition, and then you can dig into the Wikipedia page to learn all about it.
That's fantastic. So when does the Kickstarter end? When do people, when do people have until?
All right, the Kickstarter ends April 9th. We're about close to 2 weeks into the Kickstarter right now. We definitely need your help. You just need to contribute now. The earlier the better, so that we can build even more momentum, so that the more people that come on, they see that there's lots of backers behind the project, and they're more likely to come on. So we need your help at this stage. Don't wait until the last minute. Do it now and make it happen.
Okay, but what is the final date on the Kickstarter?
April 9th.
April 9th, okay. And it's kickstarter.com/ you got the
best way
go to the Song of the Stars.
It's songofthestars.org, and then right there on the main page there's two buttons. One says buy tickets, so if you live in Columbus or near Columbus, buy some tickets for our live premiere, and then right underneath that there's a big link that says go to our Kickstarter page. And that's to pay for the film. The Kickstarter is just to pay for the film. Our live performance is covered. We're good. We got funding for that. That is going to happen, and we want to make this film out of it.
Fantastic. Well, I'm pretty excited, and the lesson that I've really learned is whatever Paul wants to do, get on board. So you are the like, you may not even understand. If Paul says it's time to do a thing, then we all just jump on board and participate, and we ride this for as long as it goes. So I think I couldn't imagine someone better in position to organize such an event. So I think that's fantastic, Paul, and I will contribute as soon as this episode is over.
That's leading the charge, Fraser.
I will lead the charge with my own money, and then, but you're going to have to then push for them to do a performance here on Vancouver Island. So,
if you get me in touch with a theater, we'll make it happen.
That sounds good.
We'll get a bus.
Do one during the solar eclipse next year.
Yeah, we'll do one at the eclipse. Perfect.
Well, that's the thing. I mean, there's so many stories. Like, we picked the life stories of the stars because it was one self-contained story, but the universe is kind of a big place with lots of things happening. There's like an endless supply of stories that that we can do performances for a decade.
Yeah. Now, also, I mean, obviously with the Kickstarter, if you can't contribute money, share this out on your Facebook, share it on, and if you know people who are well positioned, like say at NPR, maybe, reach out to them and hook Paul up so he can talk to them and get the word out further.
That's an excellent idea.
I've done this before, man. Cool. Well, thanks, Paul. Now, do you want to stick around and do your normal job and participate in the space news?
I'll stick around since I invited myself to be
Yeah.
a guest. I should perform some service.
Well, then I issue you this challenge. We're going to talk about some stories from David and Kimberly, and then at some point I'm going to call on you, and I would love to hear another story that you've uncovered this week.
Okay, I'm going to start digging.
I'll give you just a couple. Yeah, I'll give you. You have like 5 minutes to find something great.
Okay.
Great. All right. So Dave Dickinson, let's talk about the ExoMars launch.
Yeah, Monday we launched a Baikonur Cosmodrome of a Proton rocket with the only mission going to Mars in this cycle. You need about every 26 months or so, Mars reaches opposition and it comes into line where you have that optimal window to launch to Mars with the minimal fuel and short trajectory time. And Mars Insight with NASA was going to launch, and that unfortunately it got bumped back to the 2018 window because it was, I forget the name of the sensor. There was a pressure leak on one of the sensors on Mars Insight. So the ExoMars Trace Gas Orbiter European Space Agency, this is a joint mission with Roscosmos, is the only mission that's going this year, and it's going to arrive in October of this year. Orbiting Red Planet, and it's also going to be releasing the Schiaparelli lander, which is built by Alina Aerospace and Roscosmos. This is actually an entry and descent testing lander for their next ExoMars mission. ExoMars is actually 2 missions. It's the Trace Gas Orbiter, and then they're going to be doing their own lander and rover in 2018. And this entry and descent, the Schiaparelli lander, is actually going to test some of the key technologies they need for descent, entry, landing, and everything that they're going to. And if they manage to land, this will be the first time a non-NASA mission has successfully landed on Mars. The Russians haven't had good luck with Mars. Everybody remembers the Phobos Grunt mission in 2011 that didn't make it out of Earth orbit. The good news is ExoMars is now safely out of Earth orbit and in the solar trajectory now heading to Mars, so it passed that hurdle there that befell the doomed Phobos Grunt mission. The Russians, it's been interested, have had good luck on Venus, which NASA has never landed on Venus, which is a much harsher environment. They've only operated there for a few hours. But Russia has had terrible luck landing on Mars. Their closest success was the Mars 3 mission, which a lot of people debate whether that was really successful. It was a lander that landed in 1970 before the Vikings landed, and it only returned like 15 seconds worth of data before it fell silent. And it returned one picture that was like really, it was like static on your TV. When you look at it, you're like, okay, that's really not a picture. But some people say that Mars 3 was the first landing on Mars. I kind of think it wasn't really. It's maybe a partial success at that. But if Schiaparelli lands, it's only going to land. It's only going to operate for a few hours. It's like the Huygens lander on Titan. It's only battery powered. So it's more of an entry and descent testing demonstration, testing this technology. It is going to do some weather sampling on the surface. ExoMars is going to actually last until the orbiter, the Trace Gas Orbiter, is going to last until, they want to last till 2022. It's going to be used as a relay for the ExoMars lander, and it's going to actually, it's got some detectors on it for, they're hunting out the mysterious source of methane on Mars, whether it's biogenic or like a geological process that's creating this, but it's going to be doing some of the same things that MAVEN is doing around Mars right now. So now Mars orbits, actually, we've got Mars Odyssey, we've got the Mars Express, which is also ESA, we've got the HiRISE is in orbit, in MAVEN, and the Indian orbiter is still the Mars orbiter mission. So once ExoMars gets there, we've got a fair amount of, we're actually getting an orbital presence around Mars. And Mars Odyssey's been up there since I think it was 2000 that arrived. Mars Odyssey's been up there a long time. It's the longest operating spacecraft in Mars orbit. So this is kind of, it was a good success for them.
Yeah, I'm really excited. And as you said, it's like there's the two critical points of the mission, right? There's the launch where many of the spacecraft get eaten, and then there's the orbital insertion, and that's the other part where they have to skim through the Martian atmosphere and try to slow down. And the galactic ghoul either takes them out at
that's the joke.
Yeah, takes them out at the beginning or takes them out in the end, and so we're kind of halfway there now.
got an appetite for apparently for Russian landers. The U.S. has actually had a pretty good for 8 landing tries. They only lost the Mars Polar Lander back in 2000. I think it was 2000 actually. So the U.S. has actually had a pretty good success rate. The only non-Russian U.S. landing attempted was Beagle 2,
And then that went away.
That didn't operate either. Yeah, that was kind of too. They just got images of Beagle 2. I wrote about that last year, I believe.
That's right. Yeah, I remember
high
that.
rise took images. It's disheartening because it looked like it was really close. It didn't quite deploy all the way because it was supposed to fold open kind of like a flower and deploy, and it looked like for whatever reason someday Matt Damon or somebody will walk up there and see what happened to it exactly. Maybe in our lifetime some astronaut will walk up and actually see what happened to Beagle 2 up
and use
close,
it to communicate home and get
you might.
so. Yeah. No, I'm definitely really excited. I mean, there's this sort of really great European presence that's coming back to Mars. I mean, we have the as you said, you've got the Mars Express, but the Europeans are really kind of leading the charge to try and get more presence there and even maybe get some samples back home. So I think this is great. Let's really hope that it makes it.
Hopefully there'll be a
second half.
Yeah,
it's going to be the exciting one, and then get down to the surface. But it'd be crazy,
exactly.
Right? So I mean, I'm trying to think. Have the Europeans ever deployed a rover before?
On Mars, no. Well,
this would be
think
about Rosetta, right? Which was a lander, but what's a rover?
Huygens. They haven't had a rover per se. Huygens is probably their greatest success on Titan.
Yeah.
That hitched a ride on Cassini, and that was kind of cool. That I always wish that it had an RTG or something on it that it could have lasted a while, because Huygens, it was battery powered, and it was kind of they didn't even know if it was going to survive on the surface because they didn't know if it was going to splash down in an ethane ocean or what was going to happen to it. So the fact they returned to any images from the surface was kind of a bonus on that. So
yeah. So this is a pretty exciting. This is a big step, and I mean, this is going to be in 2018 we're gonna it's going to be the Curiosity, or it's going to be the Rosetta of the year when this when it finally arrives. I mean, set your calendars, buckle up. It's going to be a big event when it actually makes it and tries to stick the landing and get down to the surface and first communication from the surface. So we're this is a whole new cycle and get excited.
And interestingly, this Chaparral lander is going to be roughly in the same area as Opportunity, which is still operating there. I don't think they're going to be putting it down anywhere near where Opportunity can rove over to it, because they've got the landing ellipse and it's several dozens of kilometers large, but it's interesting they're going to be in that same general area.
Yeah. Fantastic. I'm really excited. Okay, well let's move on. Kimberly, let's talk about disappearing quasars.
Sure. So quasars are one of the most powerful energy sources of the universe. Quasars are incredibly bright radio sources that are fed by large streams of gas and dust at the centers of galaxies, and this gas and dust is falling inwards towards a supermassive black hole. And as the material is falling in, it releases incredible bursts of radio energy that we can see from the very, very distant universe. In fact, quasars are some of the most distant objects that we've ever detected. And there is a team here at Penn State led by Jesse Renault, who's conducting a survey of quasars in the distant universe. And they came across something very strange in that they were looking for a quasar that they had previously detected, and when they went to go look for it again to take follow-up measurements, it was completely gone, which is very strange. So first off, they checked to make sure they were actually looking in the right part of the sky. That's always a good first check. They were looking for
is the lens cap off?
Spot. Is the lens cap off? Did they turn on the telescope?
Yeah.
Yes, everything.
Turn it back on again.
Everything was operational. They were looking in the right part of the sky, and the quasar was just gone. And there was nothing to suggest that an interstellar cloud had moved in between the telescope and the quasar in the 6 years since they had observed it. And so what they think happened was that this quasar just literally ran out of gas. Sort of like
All
a car
done.
just run out of gas and it's done and it's no longer emitting. But what's really exciting was that it had been emitting just 6 years ago. And so this is one of the very few times when we see a cosmological event happen on very, very short timescales. So usually we think about looking in the distant universe and we think that it's just static. It stays that way for millions and millions of years, and it slowly, slowly changes, and we never get to see it. But this quasar, it evolved from being a very, very bright source to completely nothing in just a few years.
Wow.
Which it's the first time that they've seen that happen on such a quick time scale. And what they want to do is they want to go back through and reobserve a lot of their previous targets and do lots of follow-ups to see if they can find out if there's any more of these and what could possibly have happened. Are there any indicators of why this happened, or does it happen to certain quasars and not other ones? They don't know. But this is an incredibly interesting event.
I mean, one of the things that I find pretty fascinating, we've covered objects that get gobbled up by the supermassive black hole at the heart of the Milky Way.
Mm-hmm.
And in many cases, it's small clouds of gas, sometimes a star, or even like an object, like, I forget, like a couple of years ago, it was like something maybe with the mass of Pluto that it's such a high energy event that when the destruction happens, enough energy is released that we can see it, in our case, 27,000 light years away, and in this case you're seeing quasar hundreds of millions, billions of
light years away.
Billions of light years away.
Yep.
But that the turning off and the turning on is so quick.
And so rapid.
Yeah, that's absolutely fascinating.
It's like a faucet that's spewing out hundreds of suns worth of material every second, and then you're able to shut it off in a decade.
Or in a year. Or in an hour. Right? Like, I wonder, do they know how fast it shut off? Or
they don't. The last time that they had observed it was 2009, and they followed up at the beginning of 2015. And between then, no one had observed it. So it could have been as long as 6 years. More likely, it was a lot shorter, and we just didn't catch it when it happened. So
is this the kind of thing that the Large Synoptic Survey Telescope would have caught, and maybe we'll catch a lot more of them out there?
It might. If it could do repeat observations of these patches of the sky, it might catch something like this happening, but my gut tells me that it's an incredibly rare event for it to shut off quite that quickly.
I forget, what's the cadence of the Large Synoptic Survey Telescope? I think
every couple of days, right?
Every couple of days, the whole staff, I think.
Yeah, 3 or 4 days.
Yeah, whole hemisphere in a couple of days. 3 days? Yeah, I'm just making stuff up. So maybe someone on in the chat can give us the actual number. Okay, so Truck Captain Stumpy asks, is there a working hypothesis to explain the disappearance? So, ran out of material. Is that the hypothesis?
That's the working hypothesis, that they had caught it in 2009, right at the sort of like the ending stages of the infalling material, and sometime in the past 6 years, the material just all got gobbled up or flung out of the galaxy, and there was just nothing left that would radiate.
Now, you might not be surprised to see what the chat is suggesting, Kimberly.
Is it suggesting alien megastructures?
Perhaps, yeah. The final stage of the Dyson sphere around the whole galaxy is the final brick was put in place.
That's an incredible suggestion I had never thought of before.
Right. Well, you might want to get on that. So, I mean, this is sort of one of these ideas then brings it back to home, right? If we look at the supermassive black hole at the heart of our galaxy, is it possible that we might see it turn on, turn off with that kind of energy? Is it a more common event than maybe we thought?
It might be, and it might be something that's triggered by, say, the merging of the Milky Way with Andromeda. There's going to be a lot of turbulent material, and that might cause a quasar. Probably certainly not in human timescales will our Milky Way become an active galactic nuclei, but perhaps in the next few billion years it could.
Yeah, we definitely know that quasars turn on and off because we can see the jets and outflows. There'll be bubbles that are blown, and then there'll be bubbles that are far away, and a little bubble closer and closer, like a train of bubbles. But that happens at like 100 million year time scales.
So you still, like, in those, so if I understand correctly, right, you've got these like blobs that are ejected when the quasar was on and when the quasar was
Right.
off, but those wouldn't explain it shutting off that quickly.
Right.
You would just see this. You would see this dimming down, and then, because I guess that was my question, right? Was, could there be some new universe, some kind of phenomenon or something that we just didn't realize that in fact when the black hole is done, it turns off within moments, right? Like, it's on or it's off. It's binary. It's as opposed to
it's like more often than I change my sheets.
Yeah. Yikes. John S. is saying in the quote, in the comments, didn't some scientists find a pulsar that had suddenly stopped for a while and then restarted as if nothing had happened? So do we see something kind of like that with pulsars? I guess it's a different phenomenon, though, right? Pulsars.
Yeah, pulsars and quasars are very different, and their pulses are produced by very different mechanisms. So with pulsars, I would be very surprised if it stuttered on and off because of the sheer amount of angular momentum you would have to get rid of and then stir it up again. For quasars, though, like Paul was saying, it depends on how much material is inflowing at any given time, and if there are gaps in that material or different densities of material at different times, the amount of radiation from a quasar will vary a lot more over time.
So Tom Van Scotter asks, is it possible that it's changing orientation so it's not pointing us anymore?
Very unlikely, I would say, simply because, again, there's just so much material you would have to move around. And to move that much material of a galaxy or a large radio jet like a quasar, that would take a lot more than just 6 years for it to turn completely away from us.
So you would see it just slowly, again, fading away.
You would see it slowly fading away, and there would still be some leftover signature or leftover material from that radio jet farther away from the galaxy, but we would still be able to see the remnants of it, and they definitely do not see anything like that.
Right. Okay. Cool. All right, Paul, what have you found?
So there's yet another oldest galaxy discovered, or furthest galaxy, or however you want to describe it. What's interesting about this was just released last week. It's a galaxy that formed about 400 million years into the evolution of the universe, which puts it over 13 billion years old. And what's interesting about this discovery is that most distant galaxies are found through what's called a lensing magnification method, where you have a distant galaxy that's usually way too dim for us to see because it's super far away. But between us and that galaxy, there's a massive, say, cluster of galaxies or a really big galaxy. And through general relativity, light bends around that cluster of galaxies, the big massive thing, and you get lensing effects, and then you also get magnification effects. So the light from that distant galaxy is magnified, and it allows us to see that galaxy even though it would normally be too dim to see. That's usually how we break these distance records to find these very early galaxies. But in this case, it came from the Candle survey on the Hubble, and this galaxy is just hanging out in the middle of nowhere. They found it in what's called the field. Using infrared, just long observing time, they were able to pick out this galaxy. It's just a brighter than average galaxy in the early universe, and we just happen to be able to see it.
Brighter than you would expect that early on in the universe?
Well, this is still like pretty much an open question. We don't know exactly, how quickly galaxies form. Obviously, they form very quickly. If already 400 million years in, we're getting some bright ones. So that must mean it's populated by young stars. Maybe this galaxy had just recently suffered a merger event. And so there's lots of gas, there's lots of shock waves that ignite a new round of stars, which suggests that maybe at this time there's already been plenty of time for massive galaxies to merge with each other this quickly in.
Wow. Cool. Let's move on. We're actually starting to run out of time. Dave Dickinson, let's go with your other story. Is this it? Is this my comet?
Unfortunately, no. This isn't the comet of the century, but it's interesting that it did brighten up. There are actually two comets that have some interesting distinctions that are passing in the very next week. One is, and they're related too, Comet 252P Linear, which was discovered back in 2000. We knew it was going to be making a close approach to the Earth. It's on a 5+ year orbit, so the P means periodic. It's got a very short orbit, short period comet. However, in the last week, it's brightened up from magnitude +11 to +5.5 I saw this morning, which is over when you do 5 magnitudes, that's 100 times brightness. So it's brightened up pretty good. In other words, it's getting up into the, from a dark sky side, it's getting up into the naked eye range. It's a good binocular comet. The only problem with it right now is, matter of fact, in the next day, it's passing less than 3 degrees from the southern celestial pole. It seems like the southern hemisphere gets all the good comets, but this comet is really trucking and it's moving north. Let's see if I can share this picture that Ian Griffin from New Zealand gave me this morning of the comet. So it's getting the greenish color on it right now, and it's passing near, it was on APOD, on Astronomy Picture of the Day, because it was passing near the Large and Small Magellanic Clouds, so it was in a very photogenic area of the sky. And it's passing by us on March 21st. It's going to pass 14 lunar distances, or 5.4 million kilometers from Earth. This is going to place it as the 5th closest comet in his known observed comet in historic history that we've observed, for its closest pass. Now, what's interesting is that there is another comet that's passing by very close to the same date, BA14 PanSTARRS, which is passing even closer at 9 lunar distances, or 3.5 million kilometers, on that same night of March 21st to 22nd. So that's going to be kind of interesting. That is actually going to be the second closest comet of all time. The former second closest comet, people have been in observational astronomy for a while. Us older folks like myself might remember Comet IRAS Araki-Alcock back in 1983 that passed pretty close to the Earth as well. It passed in the 4 million kilometer zone as well. That was all. I remember that was pre-Twitter, pre-internet. We got everything from newspapers and TV. Newspapers, for kids who don't know, where they used to actually print words on organic material, and we had to read them. We had to wait for them to be published, and so this comet came by, and most of us heard about it after it actually passed the Earth. The closest comet of all time was Comet Lexell. You have to go all the way back to 1770 for a comet that passed closest. That holds the record of all time, as 6 lunar distances, or 2.2 million kilometers from the Earth. Now, something like BA14 PanSTARRS might have, a few decades ago, you notice these are all named after these surveys, like PanSTARRS 1, Linear. These are kind of upping the game for us amateurs that are out there trying to find comets, and they're finding a lot of these faint fuzzies well before any of us can go out there. BA14 PanSTARRS, unfortunately, although it's passing really close, it's really tiny, so it's only going to be like 12th magnitude. The folks over at the Virtual Telescope Project, on the night of March 21st, starting at 22 Universal Time, they're going to do a live broadcast from their telescope, actually showing this little faint fuzzy. But 12th magnitude is a little faint for, if you've got a big Dobsonian, you might be able to go after it. The other problem we get over this next week, unfortunately, is the moon is going toward full. So that is hopefully, I'm hoping 252P Linear brightens up once it heads up north. Next week, I'm here in Seville, about 30 degrees north. We should start getting good views of it about a week from today as it goes up through Scorpius. That shows how close it is. It's really moving. If it's going in 1 week from the southern pole up to the ecliptic and that region around Scorpius, it's trucking. It's moving, like, I believe it's moving about 10 degrees a day. that's a lot of ground for a comet to cover, but that shows it's moving really close to us. So hopefully Northern Hemisphere. Oh, go ahead.
Oh, I was going to ask you just how big of a telescope you took on the airplane with you to be able to see it.
I have my image stabilized binoculars, which are they give you about the equivalent of a small telescope. That was my one concession, along with my DSLR and my travel tripod that I did manage to bring with me. The image stabilized binoculars are awesome. They're expensive and they're worth every. Even when I built an observatory in Arizona, I still use those binoculars more than the telescope itself because they're really handy.
Yeah, I'm going to second that. We did the Not the End of the World cruise a couple of years ago when we were on a cruise ship, and we were doing a bunch of observing nights out on the ship with a bunch of the fans, with Pamela and myself, and a couple of people had brought those image stabilizing binoculars. I think Canon makes them.
Yes.
And so you're there, and the ship is kind of rocking, and you're looking up in the sky, and then you press the button, and then everything just stops. And it's just you're looking at a photograph, but with both eyeballs. It's just an amazing experience.
I get so used to them when I go to another pair of normal binoculars, it just doesn't feel right. You get so used to the image stabilized technology, and they've been around for about a decade too.
Yeah. They are not cheap though, so
no.
So you are going to need to write some more articles, I think. Yeah. Cool. Well, that's awesome. All right. So, Kimberly, let's give us your last story.
All right. So it's a kind of a disappointing story, I have to admit. But
never mind, maybe.
Oh.
No. Go ahead.
If you remember, a few weeks ago, Nicole and I reported on a very exciting discovery of the afterglow of a fast radio burst, which, if you remember, is a very short microsecond pulse of very, very energetic radio waves. And these happen occasionally randomly, but what was so exciting about it was the team thought that they had discovered the galaxy that this fast radio burst had come from and had gotten a distance to it, which let them calculate the amount of material that this burst had traveled through, which supposedly solved this very important cosmological missing baryon problem. Well, since that time, a number of other teams have done follow-ups on the galaxy that this FRB had supposedly come from, and have continued to see radio emission from this galaxy, which should not happen with a fast radio burst. So instead of this galaxy having produced a fast radio burst, we think that that galaxy now is just a regular old run-of-the-mill active galactic nucleus, which did not produce a fast radio burst. So, womp womp. What that means is that the missing baryons are still missing. We don't know yet if they are there or not. And it is a cautionary tale about overestimating how many FRBs are associated with this type of radio afterglow that they had seen. So hopefully in the future they will be able to apply some of these new constraints, and we won't have quite as many false alarms as this one. So it was very exciting for about a week or so, but now we're back to having missing baryons.
Paul, that sort of hit your wheelhouse, didn't it? I mean, sort of, searching for through those cosmic voids, looking for those big areas, trying to sort of see what's going on.
Yeah, so I did a research project along with Amy Furness and Joel Premack at UC San Diego a year ago, 2 years ago, something like that, where we were looking at blazars, the super high energy explosion events, and we were looking through cosmic voids, and we discovered that the only reason we can see these high energy events is because we happen to be looking through cosmic voids. If you look through a dense part of the universe, all the particles and stuff from the explosion their paths get curved, so they end up not reaching the Earth.
Kimberly, I mean, the way this went down, right? Huge mystery solved.
Yeah.
Oh, wait, mystery not solved. I mean, we saw this with the primordial gravitational waves, faster than light neutrinos, cold fusion. I mean, there is, how can scientists who are working in these fields, try to get other people to help replicate the results, try to sort of get a sense of what they're doing, but not necessarily let the story get away?
I don't know so much that they have control over it. I mean, even with this FRB discovery, they followed all the right steps, and they got it peer-reviewed, and they did follow-up observations, and everything pointed to this galaxy being the source of the FRB, and the solution to their cosmological density, it was almost perfectly what they expected. And so it was a very compelling argument. They went through all the right steps, and it was very exciting, and then they just got more information. So I think they did the best that they could with the information they had, and now we're finding out more and more, and that's how the scientific process works. And unfortunately, with an answer that is so exciting as potentially finding the missing baryons, sometimes the story just gets away from you. Sort of like alien megastructures.
Kind of like that.
Yeah.
Kind of like alien megastructures.
Yeah, there's usually a difference between the press announcement and the actual paper. Usually the actual paper has all the right...
caveats and everything.
Yeah, the caveats and full explanations saying this is one potential hypothesis that we have strong evidence for, blah, blah, blah. And then the press release is, we discovered...
the most compelling story.
Right. It sort of fits somewhere in between not discovering a supernova during a live star party. It sort of falls
I remember that.
That falls in that spectrum. You were there. That was your job.
It was.
Yeah. And now you have a complex. Every time you look at a picture, you're looking for supernovae. So we understand. And this is the point, right? We learn from our mistakes. Cool. Well, we've sort of reached the end. A couple of people I'm noticing in the chat just thought the show starts now, and that's because of the daylight savings time. So I apologize. I think I really apologize for all countries that follow daylight savings time because it's a ridiculous idea, and I really wish we didn't have it. So, but the solution is to go into YouTube and make sure that you get notified every time we do a show. And I don't know the exact way to do it, but go to your YouTube settings for this channel, and there should be a way to get notified when live events are going on and whenever we publish a new video. So you should be able to do that. David Joseph Wesley saying that Hubble's supposed to turn 26, which is crazy. Okay, so David, where do people find out more about you and what you're working on?
Yeah, this week I was active on my own site, AstroGuys with a Z, and I'm at AstroGuys with a Z on Twitter. You can follow me on Instagram. I'm Instagramming all my travels and everywhere. We're mostly hanging out in Spain until the rest of the northern hemisphere warms up before we head north again. I was active on Sky Telescope, Universe Today, and we have a crewed launch of a Soyuz coming up in less than 2 hours. I'm probably going to move over coverage of that on Twitter right after this. Launching out of Baikonur, heading to the ISS in less than 2 hours. NASA TV coverage is going to be going live in about 28 minutes. So watch the launch. It's always cool to watch launches.
And maybe if you keep heading east, you'll eventually be able to be there for something live.
I've never been to Russia or Kazakhstan. That would be too cool. I definitely would go.
There was a great series of photographs that came out last year of the Buran facility. I think it's in Kazakhstan.
Yeah.
And completely abandoned, half dismantled. Yeah. So if you want a place to go, that would be great. Kimberly, where do people find out more?
People can find out more by following me on Twitter at AstroKimCartier, by going to my website and blog at www.kimberlycartier.org. And next month I will be in the Buffalo, New York area giving a talk to the Buffalo Astronomical Association at their annual banquet. So if you're in the area or can drive on by, come by and see me.
Fantastic. Paul?
Yeah, you can find more info about me at Twitter and Facebook, Paul Matt Sutter. And over the coming weeks, I'll be tweeting like behind-the-scenes photos and backstage information as we're preparing for our April 21st premiere of Song of the Stars. And you can visit songofthestars.org for all the information about that amazing collaboration that I'm lucky to be a part of. And I'd like to give a huge shout out to Helge Brokog, who has already contributed to the Kickstarter.
Fantastic. Cool. So you mentioned your Instagram work, David, and I think I'd like to take credit for dragging you over onto Instagram as I do to the various social networks that I'm active on. So we've got just shy of 75,000 people following the Universe Today Instagram page, and we're doing something kind of fun, which is that I'm handing the keys over to different photographers every day. So if you want, if you're an astrophotographer and you're posting pictures over on Instagram, use the hashtag Universe Today, and that'll sort of let me know that you're taking pictures, and I'll check out your feed, and you may get an email from me or a direct message from me, and with a pair of keys in them. Well, virtual keys, and then you can take over the account for the day. We're having a lot of fun and some really great photographs. So if you haven't already, follow Universe Today on Instagram, and if you haven't already, follow, of course, this channel on YouTube so that you'll get those notifications. John Marcello just said go to where it says subscribed on the Fraser Cain YouTube channel, then click the gear and check send me all notifications for this channel. I think that's great. I would even maybe have them notify you in your dreams, have them notify you on television, whatever it takes for you to make sure. Get a phone call just to make sure that you get a chance
Messenger
to catch
pigeon?
this show. Exactly, yeah. So you never miss a show. Awesome. That sounds perfect. Okay, great. So thanks, everyone, for watching this week. Thanks to all of our panel and our special guest, who's also on our panel. I'm not sure which one you are, Paul. And now, as the last action that you must do, go to Kickstarter and participate in the Song of the Stars Kickstarter. I'm going to go do that right now. All right. Thanks, everyone. We'll see you all next week.
Thank you.
Bye.